Alright, so in this video we're going to talk about a solution, and then we're also going to talk about the process to create a solution. So if you remember, a solution is a type of homogeneous mixture. So a homogeneous mixture is going to be a mixture where you have a uniform composition, so it looks and appears like one thing. So no matter where you go in the homogeneous mixture, you should be able to sample the same percentage of everything. Now, a solution has two parts. It has a solute and then a solvent. So the solute is the substance that you're dissolving. That could be liquid, it could be gaseous, it could be a solid. The solvent is the substance that you dissolve the solute in. Now, when we create a solution, that is called solvation. So there are three main things that happen when we create a solution. So the first thing, the solvent particles need to separate from each other. So when we have an aqueous solution where we have water as a solvent, the water molecules need to separate from each other. Then the solvent will surround the solute particles and then pull the solute apart. So the solvent separates, the solute separates, and then you put the solute and the solvent together. Now, when we do this, when we pull the solvent particles apart, that requires energy. Anytime that you pull things apart that are attracted to each other, it's going to require energy. So that is an endothermic process. If I take the solute and I'm separating the solute, that means that it's also going to be an endothermic process because I'm taking things that are attracted to each other and separating them. The last part is when the solute and the solvent come together. Well, when you put things together that are attracted, that releases energy. So the overall process to create a solution could either be endothermic or exothermic. It really depends on how much energy it took to separate the solute and the solvent, and then how much energy was released when you put those things together. Now, when you are separating the solute, it can happen one of three different ways. It really depends on what kind of substance you start off with. So dissociation is when I take an ionic compound. An ionic compound is already composed with charged particles, and then I separate those charged particles out. So I'm pulling the ions apart from each other. So if I have sodium chloride, I'm pulling the sodium ions away from the chloride ions. That's dissociation. So you're starting with something that has a charge already and then just separating them out. All right, ionization is when you take something that does not have a charge and then you create ions in the solution. So anytime that you take an acid and you put it into water, you're creating ions. You create something called a hydronium ion and then usually some other type of ion. So you're going to create ions in the process of ionization. So you're putting charged particles in the solution. Molecular solvation is just where you're taking a solid and you're just separating all the pieces apart. So if I were to take, if I take glucose, now if I look at glucose as a whole, when I can actually see it, all of those molecules are bonded together, okay? But you're just pulling the molecules apart. So the molecule will stay intact, it's just you're pulling them apart. You're pulling the molecule apart from the other molecules. So there are no charged particles when this happens. Now, because we can put charged particles into a solution, they can, if you do put ions or charged particles into a solution, it can be electrically conductive. So if I were to put something in a solution and then there are no charged particles being put into the solution, it's a non-electrolyte. So these non-electrolytes occurs when you have molecular solvation. So you do not have any charged particles in the solution. Now, if you were to put something in the solution and you create some ions, that's in a weak electrolyte. So if you were to take a weak acid, a weak acid like acetic acid, which is found in vinegar, and put it into a solution, you create some ions in the solution. So it is conductive, but it's just not very conductive. And a strong electrolyte is where you've got a lot of charged particles in the solution. Now, this will definitely happen if you take an ionic compound and dissolve it into water, because all you're doing if you dissolve that ionic compound is you're pulling all of the ions apart. So you will have lots of ions. You could also have ionization happen where you make lots of ions with like a strong acid. A strong acid or strong base will create a lot of ions in the solution, and it will be very conductive. Now, just because you put two things together does not mean it will create a solution. So like will dissolve like. So if you have a nonpolar substance, it will dissolve with another nonpolar substance. So if you have something that's oily, it can dissolve something else that is oily. Oil and water will not dissolve in each other. That's because one is very polar and one is very nonpolar, so they will not mix together. Now, polar and polar will also mix. So like dissolves like. So if you take something like water and mix it with ammonia, those things will be miscible. So there's miscible and then there's immiscible. Miscible means that they will mix together. Immiscible, with an I in the front, will not mix. So a nonpolar with a polar substance will not be miscible. They will be immiscible. Now, soap is kind of funny. Soap actually has both parts. It has a polar head and then it has a non-polar tail. So right here at the end here, this is the non-polar tail, and it has a polar head. Now, the reason that soap is such a good cleanser is because it has both of these components. So a lot of things that we need cleaning contain non-polar substances like grease, and then you have water. Well, water and grease will not mix together. But if you have soap, the soap will bond with the polar water with the polar head, and then the non-polar tail will bond with the grease. So you're getting the water and the oil to mix because the soap has both components.